everyone, we are on day 5 of our Unit 5 notes in geometry. Make sure you have the notes out, and I'd recommend you have some colored pencils or markers. Different colors will definitely help your learning in geometry just so you can distinguish between the different sides. So we're first going to start with exterior and interior angles. Okay, so talking about the different parts to that. All right, so let's say I have angle 1, and let's say angle 1 is 100 degrees, okay? And let's say angle A, measure of angle A is 60 degrees. So, based on a theorem, it says 100 degrees has to be greater than the 60 degrees, which is going to be the case. So that exterior angle needs to be greater than the corresponding remote interior angle. So think of the one that's opposite of that. Okay, and there are 2 of those, so let's say angle B is therefore 40 degrees. So then I have 100 degrees is greater than 40 degrees. Okay, so again, the exterior angle is greater than each of the angles inside. Why? Because of the exterior angle theorem, which says that angle A plus angle B actually equals angle 1. Okay, so we have 60 degrees plus 40 degrees, and that equals 100 degrees. Okay, so that's why this is the case. The exterior angle is greater than the remote interior. So what we're going to do now is we're going to actually label and look at the different relationships in this figure. You can definitely draw it again, use different colors to kind of distinguish so you can see what I'm looking at. So we're looking at this 14 right here. So we're going to be looking at the triangles that are connected to angle 14. So we're going to look at this small triangle. So what are the remote corresponding interior angles to angle 14? Well, that would be 4 and 11. Okay? So those angles are less than angle 14. All right, now let's look at another one. Let's look at this big triangle right here. This big triangle is also connected to the angle 14. Okay, so that would be, what would be the corresponding interior? Well, that would be 2 and then 3 and 4 together. So angle 2 and then angle 3 / angle 4 put together. All right. Now let's go the opposite. Now if we were looking at angle 5, we want to see which angles would be greater than angle 5. So where is angle 5? Well, angle 5 is actually in the inside. So we're going to now do the opposite of what we just did. So if angle 5 is on the inside, we want to know what is it connected to. What exterior angle is it connected to? Well, it's not connected to 14 because that's not a corresponding remote angle, okay? Those are right next to each other. So we're looking for an exterior angle that is on the, again, outside and is corresponding to that angle. So 5 would be corresponding to 16 if I drew that big triangle. And if I drew this little triangle right here, well, what is it attached to? It's attached to angle 17. Okay? So we're trying to look for that outside. So again, if I have that triangle right here, we have an angle right here. Okay? So that's angle 17, and that's angle 5. Okay? And then this is angle 16. All right, so looking at the relationship between, again, the interior and the exterior angles. Now let's try this again. So I want you to find angle 4, okay? Determine if is it an exterior angle or an interior angle, and find the angles that are less than angle 4. All right, so angle 4 is an exterior angle to what remote corresponding angles on the inside, okay? So in the green triangle example, it's 2 and 5 right here. And then in the blue triangle, it's 2 and 8 together, and then angle 7, okay? So angle 3 would not count, okay? That is right next to angle 4. That's a linear pair with angle 4, okay? That is not what the theorem talks about. So that's why angle 3 would not be in the situation. All right, now let's look at B. So now let's see what angle 8 and what relationship it has, okay? So angle 8 is actually on the inside of this triangle. So could I count angle 1? No, because that would create a linear pair including angle 2. Okay, so we have to find a remote exterior. So we have to find the exterior angle that is kind of opposite of angle 8. Okay, so geometry is a lot of seeing the image in different ways. Okay, so here's my triangle that angle 8 is hanging out in. Okay, and we want to find the exterior angle that goes with angle 8. Okay, well, we've got angle 9. That is outside of the red triangle, and that will be greater than angle 8. And what else is on the outside of the red triangle? Well, it would be angle 5. And there we go. All right, excellent job. Now let's move on to the next theorem. So what we're talking about is the relationship between the side and the opposite angle. Okay, so let's just look at that section just on its own. Okay, it might be a little blurry, so let me see if I can clear it up. Let me see. There we go. All right, so if one side of the triangle is longer than another side, the angle opposite the longer side has a greater measure than the angle opposite the shorter side. Bottom line, folks, angle this side is 9. So the angle opposite of it has to be greater than the side that's smaller. Okay, so let me put some numbers to this. So if 9 is this side and the angle is 60 degrees, the side that is 7 has to have a smaller angle. Okay, so we can put that over here. So 9 is greater than 7. So therefore 60 is greater than 40. So we're just talking about the different relationships between angles and sides that are opposite. So it's the opposite side that goes with it. Okay, and now the other theorem is just the opposite concept. Okay, so if this angle is 100 degrees, the side that's opposite is going to be greater. So let's say that this side is 15. Okay, so 100 degrees is greater, 15 is greater. Okay, so if this angle is 45 degrees, the side that's opposite has to be less. So let's say that that's 9. Okay. All right. So an angle of 110. Sorry about that. An angle that's 110 degrees is going to be greater than an angle that's 45 degrees. And the same with the sides. A side of 15 is going to be greater than a side of 9. So it's just talking about the relationship between the angle and the side that's opposite of it. Okay, so let's draw another example. See if you can have room and color code it for me so then we can see this. So I'm going to pick the color green. I'm going to make that angle green, and then the side that's opposite of it, I'm going to also make green. Okay, so that angle goes with that side. Okay, I'm going to make another one, so I'm going to make B orange. That angle is going to go with the opposite side. Okay, and then last, I will pick purple. C, the angle C, is going to go with this side. There we go. A little bit of color in. Here we go. Okay, so then you know what angle goes with what side. Okay, so if C was 50 degrees and B was 70 degrees and A was 60 degrees, which side would be the greatest? Well, what is the biggest angle? The biggest angle is 70, is this B. So that would mean that the biggest side would be AC. Okay, AC is the biggest side because angle B is the biggest angle. All right, so let's do some examples and see if we can work this out. Before that, this is a proof just to prove that why this is the way it is. It's just talking about the relationships between the exterior angles, the interior angles, and that information. Okay, we can move on. All right, list the angles of ABC in order from smallest to largest. All right, well, what can we do? Let's look for the smallest side. Well, the smallest side is AB. So what is opposite of the smallest side? Well, that's angle C. Okay, what is the next smallest side? Well, it's this side, which is 14.3. What is the angle opposite of that? Well, that's angle A. So what's the biggest side? 15.7. What's the angle opposite of that? Angle B. So the angles that are smallest to largest is CAB. All right, now I want you to try that for the next one. Again, from smallest to largest, you're going to list the angles. So if the smallest side is 17.4, the angle that goes with it is angle X. Okay, you finish this up. Pause the video, finish it up, and then I'll see you on the next problem. All right, now we're going to do the opposite. So list the sides of ABC in order from shortest to longest. So what is the smallest angle? Well, the smallest angle is 45 degrees. So what is the side that's across from that? AC. Okay. All right, what is the next smallest side? Well, that is 55 degrees. What's the side across from that? Well, we need a B right here. The B went away, so AB. And then the biggest angle is 80 degrees. Well, what is the side across from that? CB. There we go. So we listed the sides in order from shortest to longest. Now I want you to try the next one with RST. Okay, so RST. The smallest angle is 43 degrees, so now you will list the segments that are across the way. So list the 3 segments from shortest to longest. Questions in class if you have any, and we will see you online or in person. Have a great day.